Hi everyone. So today's lesson is on something called complex numbers, and this really isn't anything new. It's just taking what you learned yesterday with the imaginary numbers and combining it with the real number system. So you'll see here in our definition, a complex number is a number that's made up of both a real and an imaginary component. And what's kind of weird about these things is we call them numbers, but to you they're going to look more like an algebraic expression. It's not just a single number. Here's what complex numbers look like. It's a real number, which we use A to represent, plus or minus an imaginary number, and that's where that I comes from, okay, is the imaginary number. So we have a real component and we have an imaginary component, okay? And so this expression right here is what's called a complex number, okay? So most of what you're doing as far as simplifying these things, you're just using your regular rules of algebra. We're going to kind of treat that I like an x. So all the same rules that would apply if it were an x are going to apply to the I. The one thing I do want you to just keep in mind here, we talked about this yesterday, is that I squared is equal to -1. So anytime you're doing some simplifying and you end up with an I squared, you want to make sure to simplify that down to a -1. What that does is turn your number, your imaginary part, back into a real number, and then you can combine it with any other real numbers that happen to be there. You'll see what I mean in just a minute. Okay, so let's take a look at that first example there. And the one thing that gets people with this is I see that there are two parentheses here, and for some people their first instinct is to start foiling, start distributing, right? We don't want to do that because of this plus sign. This plus sign is indicating to me that I'm adding these two things together. And when we're adding, all we're really doing is combining like terms. So, for example, 2 plus -7 makes -5. And 3i plus 2i makes 5i. And then that's just it. We leave our answer like that. Okay. Now, this second one we do have to be a little more careful with. This minus sign is applying to both of these things. So we want to be subtracting the 4 and subtracting the 2i, okay? It might help you if you rewrite it, and I'm leaving this first parenthesis alone because there's nothing out in front here that would make me change that parenthesis. But this minus sign applies to the 4, so we're subtracting 4, and we're subtracting 2i. Some of us refer to this sometimes as distributing that negative. Okay, but now, just like before, I'm going to do 5 minus 4, and I get 1. And -6i minus 2i is -8i. And then that's how we leave our answer. Okay? All right, so this third one, that one is multiplication. This is the distributive property. This is saying take 2i and multiply it by both of these things. So 2i times 6 gives me 12i. And 2i times 4i, just like with x's, would give me 8. Whoops, and that's +8. And then from I times I, we get I squared. Okay? Now, remember what I said up here. Anytime you see I squared, it's really a -1. So this 8i squared that we're seeing right here is really a -8, like a real number, -8. Okay? And so what I'm going to do with that, when I write my final answer, I'm going to put that -8 first, and I'll explain why in just a second. But so the -8 is going first, and then plus 12i. And that's just the format we write these things in. We always put the real number first and then the imaginary number. You see this setup up here? You're going to see questions on your homework that say write this in a plus bi form. That's all this means, is to write it so that it looks like this. Okay? Okay, and then this last example, we are going to do FOIL, but I want you to take a second and look at the difference between this expression and this expression, okay? The addition versus the multiplication. These two are right next to each other, and that's what indicates that I'm going to FOIL here. So I'm going to do 4 times 6 is 24. 4 times 7i is 28i. -3i times 6 gives me -18i. And then here, negative 3i times 7i. Well, negative 3 times 7 is negative 21. I times I gives me I squared. Okay, there's some simplifying we can do here. Just like normally, I can go ahead and put these two middle terms together. But then the other thing I can do is this negative 21i squared. That's really like negative 21 times negative 1. So this whole thing is just a plus 21. Again, that came from negative 21 times negative 1, which becomes positive 21. So now I can combine that 21 with this 24, and I end up with 45. And I can combine these two, and that makes 10i, positive 10i. Okay, so you should always be able to simplify these things down to just two pieces, a real number and an imaginary number. Okay? Okay, so that's simplifying with complex numbers. Again, we're just following most of our normal algebraic rules. Okay? I want to take a look at this thing called the complex conjugate. Okay? And there's a definition written there in words. Okay? It's probably not going to make a whole lot of sense in words, but when you see it in symbols, it'll make sense. A complex number formed by switching the sign on the imaginary part of the existing complex number. Here's what that means. If I have 3 plus 4i, the complex conjugate is 3 minus 4i. Okay, all I did was switch that plus to a minus. Now, these aren't equal to each other. You'll notice I didn't say this equals this. It's not the same thing, but there's a purpose for this. Knowing these two things have a relationship is important, and that comes under, but why? So let me show you. If I take this and multiply by its complex conjugate, meaning FOIL, like what I did just a second ago, watch what's going to happen. So I have 3 plus 4i, 3 minus 4i. When I multiply this out, I get 9 plus 12i. Oh, I'm sorry. That should be a minus 12i. Start over here. 3 times 3 is 9. 3 times negative 4i gives me negative 12i. 4i times 3 gives me positive 12i. And 4i times negative 4i, this is the one to be careful on. 4 times negative 4 is negative 16. And I times I makes this an I squared. Okay? So just like we did a second ago, I'm going to put these two middle pieces together, except I want you to notice that they're both the same, except one's negative and one's positive, and that makes them cancel out. Okay? And then, like we did a minute ago also, this negative 16i squared becomes a positive 16. So when I put these two things together, I come out with just 25. Okay? And so the thing that's significant about that is that there's no longer an imaginary piece. No I. Okay? There's no imaginary piece to this anymore. That's the value of a complex conjugate. Is if you're in a situation, and we're going to talk about these situations in just a minute, where we don't want our answer to be imaginary or complex, multiplying by a complex conjugate can turn something that's complex into a real number, a whole number. Okay? Now, there's not really a shortcut for it. You can't just say, oh, they cancel out, because there is a number piece of this left. But the i's in the middle cancel out, and that's the important part. Okay. So on the back here, whoops, I believe you just have this one example. Okay, and we're going to talk about that complex conjugate thing again here. It says to simplify this. Now, I've mentioned this before. I'm going to mention it again. We can't simplify pieces. So we can't go 2 and 6 and make that a 1/3. And we can't go over here and just cross out the i's. Don't do that. Because you can't cancel out addition, which is what this is, using division. Okay, I can't make addition go away by using division, all right? So I can't cancel out pieces of an addition problem. Okay, so what do we do? Well, and what's not simple about this to begin with? Okay, what's considered to be not simplified? It's important that we know that. You may have heard this before, maybe in geometry. I'm not sure that I've mentioned it yet this year. But there is a rule in math that says we are not allowed to have square roots on the bottom of things. Okay, we're not allowed to let this happen. Okay, it's called having an irrational denominator, and that's just something that way a long time ago mathematicians decided we weren't going to do. Okay, so the problem with this thing is that I down there is really a square root of -1. Do you remember that? That I is equal to the square root of -1. So by having an I on the bottom, we're allowing a square root to be on the bottom of a fraction, and that's not okay. So when it says simplify, really what it's asking us to do is rationalize, okay? And rationalize means get rid of that square root that's on the bottom that we don't like to have down there. Well, do you remember what we just talked about? That if we want to get rid of an I, all right, if we want to get rid of an imaginary number, which is a square root, we can use a complex conjugate. So I would really love to multiply this bottom piece by its complex conjugate of 6 plus 7i. Okay? But thinking about your rules of fractions, I can't just multiply the bottom by that 6 plus 7i. I also have to multiply the top by 6 plus 7i. Okay? So I have to multiply top and bottom the same way. Now, that's not going to cancel out the i's up on the top, but we don't care about the i's up on the top. It's the one on the bottom that's causing us some problems. So this is just going to take a whole lot of FOIL. Okay? You've got parentheses here, you've got parentheses here. I'm going to multiply across on the top and then multiply across on the bottom, and then I'll do all my simplifying. So up on the top here, 2 times 6 is 12. 2 times 7i is 14i. 3i times 6 is 18i. And 3i times 7i would be 21i squared. Okay, I'll clean that up in just a minute, but let's do the bottom. So 6 times 6 is 36. 6 times 7i is 42i. Negative 7i times 6, that would be negative 42i. And then negative 7i times 7i would be negative 49i squared. Okay, go ahead and pause if you need a second to catch up with that. Okay, so now, like we did before, I'm going to put these two pieces together, right? I'm going to turn this 21i squared, that's really a 21 times a -1, so this whole thing is just going to become a minus 21. On the bottom, I'm going to put these two things together. However, you'll notice that they actually cancel out when you do that. And that was the whole reason we did this, right? Was to make this happen, okay? And then this minus 49i squared will become a plus 49. Right, so I'm going to do all of that together. 12 minus 21 here is -9. 14i plus 18i makes 32i. And then on the bottom, I have 36 plus 49, which, let's see, that's 85, I believe. Okay. And this thing right here is your final answer. Okay. Just to point out one thing, I'm okay with us leaving our answer in this form. There are going to be some situations, kind of like when we did quadratic formula, that all three of these numbers can be reduced. Like, for example, all three of these could be divided by 2, and then I would want you to do that. Okay, we'll talk about that when that shows up, like on your homework and stuff. But sometimes you're going to be asked the question, write it in A plus BI form. I just want to point out that this is A plus BI form. Technically, if we wanted it in the correct form, we would split it. So we would do -9 over 85 plus 32 over 85 times I. That's the same thing. So this is A plus BI, okay? I don't require you to write it this way. I don't require you to split it like that, but I just want you to recognize that this and this are the same thing, and that's why we can get away with saying that this is A plus BI form. Okay, so that's about it for today. Like I said, I want you to try the homework. There are a couple that you may, fumble through a little bit, but just remember your rules of math. Let's see how you do. We will make sure to go over this when I see you again, I believe, on Friday. Yeah, so homework tonight is Lesson Master 6-9B. Go ahead and get to it.